In this video, we will talk a bit about implicit plots, both in 2D, we'll recall some of what we've seen in our previous calculus classes, and then now in 3 dimensions when we've got 3 variables. So, in your calculus class, you may have previously graphed something like sine of y equals x, or this second equation. I'll do that here pretty quickly. You can think about it. When drawing a circle, it's always easier to draw it and then put the axes in rather than the other way around. So the distance equation, you may have seen this before, but just to recall, here's what we have in 2 dimensions. And in 3 dimensions, it looks pretty similar. You can take a look in the textbook for a proof of this, or at least some justification for why this is true. So we'll come back to that in a moment. I should mention that the distance formula that we used in 2D really gives rise to that formula for the circle that we saw above. So I'll let you think about why that's true and what that equation is really saying. So we can graph an implicit surface in 3 dimensions. We'll head over to CoCalc to do that and see what we have. So here we are back in CoCalc. The command we want to use is implicit plot 3D. I put here the equation that defines all the points we want to plot. The double equal sign here, well, we can contrast that with, up here, a single equal sign, which is used to assign a name of a function or a variable to a value or to an expression. A double equal sign is something that we want to check is true or something that we want to guarantee is true. So here we want to make sure that this expression on the left-hand side is equal to 36. We're not setting them equal, we're checking to see if they're equal and plotting the points where that's true. And then here, these are the bounds in the x, y, and z directions. So we'll shift enter to evaluate this. And, oh, I'm glad this happened. So in Sage, we need to tell it, or in CoCalc, we need to tell it when we're using a variable. When we define a function, as we did above, f of x, y, it automatically knows we're talking about x and y as functions because they're inputs for, x and y as variables because they're inputs for a function. Here, it's not obvious. So we need to declare that that's true. We only have to do this once. X and y are already variables, but I'll do this anyhow. And that should do it. And here what we have is an ellipsoid, kind of an egg shape. And you can mess around with this. You can look in the x, the y, and the z directions to see what the radii are in those directions and how that connects to the original equation. And now in this question, we'll make use of that distance formula. We want to graph all the points where the distance from 1, 0, 1 is the same as the distance from -1, 0, -1. If you want to take a second, pause the video and think about what that should look like. So let's check it out. Here, we'll just write that statement as 2 things that have to be equal. On the left-hand side, the distance between x, y, and z and the point -1, 0, -1. On the right-hand side, the distance from x, y, z to the point 1, 0, 1. Oops, and I forgot my 2 in there. And then if we square both sides, cancel out almost everything, we're left with minus x equals z. You can probably guess what that should look like. We've seen something very similar in class, but let's head over to CoCalc and see what we've got. And now here, you can probably guess what this should look like. We don't need to declare again that x, y, and z are variables. We've already done that. But if we go ahead and ask CoCalc to graph this for us, there we've got it. So in the x, z plane, the profile of this plane that we've just graphed looks like a diagonal line, as we'd expect. And as we move through the y values, there's really no change. So I want to take a second just to mention to you that every graph is an example of an implicit plot. So it's not that these are two separate things that we have to think about in different ways. Every graph is a type of implicit plot, specifically when we're looking at points x, y, z that satisfy this equation. So it's sort of a unifying theory.